Good morning, everybody. Welcome back to Math 105. How much do pirates pay for corn? They pay a buccaneer. Okay, so our plan for today is going to be to finish off Standard 1, and finish off the worksheet packet that we started in class on Friday. Upcoming office hours are right after class today and Wednesday and from 2 to 3. And tomorrow I'll also have office hours from 10 to 11:30 in the morning and 1:30 to 2:30 in the afternoon. As far as homework goes, it hasn't been posted yet, but I do plan on officially assigning the Standard 1 quiz later today. And when that's up, I'm going to send out an email to everyone with instructions for where to go to access it and how to do it. But basically, the plan is the quiz will be available for several days, and once you start it, you'll have 10 minutes to work on it. It's a 10-minute quiz, but you can start it basically at any point during the time period, which I'll tell you in the email. I ran into some snackings yesterday, but should be up. I expect that it'll be up this afternoon. Any questions or comments before we get started today?
How long will the quiz be available? The entire week? Or?
It's probably going to be well, since this is the first one, I'll probably make it a little bit longer. It'll probably be like over a 3-day period. And I'll let you know. I'll say, when I post the quiz, I'll send an email saying, quiz is up now. You have until X time to complete the quiz. If I put it up this afternoon, the plan would be to make it due on like Thursday evening. Any questions? Okay, let's get cracking. So last time we talked about what is math as sort of a prelude to the course, and then talked about the idea of what is a mathematical statement. A sentence which can be classified as being unambiguously true or unambiguously false. Something along the lines of, you are all students in Math 105 would be an unambiguously true statement. You are all students at Harvard would be an unambiguously false statement. And you are all the best students ever would not be a statement because there is some ambiguity to it, even if I don't think so. So, talked a lot about examples of statements and non-statements last time. Today, I want to start out by talking about how to negate a statement. So if you're following along in the packet, we're going to start on page 3. And in general, we're going to talk today about kind of negation of statements, what it means for statements to be logically equivalent, and what does it mean to have set kind of collections of statements, like pairs or trios of statements, say, that are contradictory in some way. So, in general, if we're ever given a statement P, so P here is going to be used as a variable that's used to refer to a statement. So given a statement P, we can construct another statement called the negation of P. We can find the negation of P, which we'll often refer to by putting a little squiggle before the P. That is true whenever P is false, and is false whenever P is true. So this is true whenever P is false, and vice versa. So in other words, the negation of P is just going to be a statement that has the exact opposite truth values to it as the original statement. So let's look at an example. Let's say that our statement P is, it is snowing. And go ahead, and because my last class was trying to really push my logical buttons. Let's say it's snowing outside. They can avoid the sorts of false scenarios we had in the previous class. I would like to negate this statement, meaning I would like to be able to come up with a statement that's true if this statement is false, and also want my negation to be false whenever this statement is true. So what would be an example of a way that we could write the negation of the original statement? It is not snowing outside. Adding that one word, not. Any other ways? So a few hands go up here. What would be another way we could try and negate the statement?
It is hot outside.
It is hot outside. How else? Like there are several ways we could try and write negation for this thing.
It is snowing inside.
It is snowing inside.
I just have a question about the last one, because if the one of is snowing inside, if that one's true, that doesn't especially mean the first one's false. So is that really a negation?
We'll come back and look at each one of these individually in just a second. Yeah, sorry, maybe I should say. Right now, I'm just kind of getting your all's ideas for ways we can negate, and I'll throw them on the board, and then we'll go through each one individually and talk about does that work as a negation. But yes, I think you have a good thought. Hold on to it for just a second.
It is only snowing inside.
It is only snowing inside. Ooh. It's not also. I'm curious. What do you have in mind? What else could be happening inside?
Well, it is not snowing outside. The only place where it's snowing is inside.
Ah, gotcha. It's only snow. Okay, you're saying the only place where it snows inside. I was thinking it's only snowing. It's not also raining down hail and lava's erupting and such inside.
The usual in Dow science.
Wouldn't be too unusual around here. Any other? I'm going to add one of my own. There is no snow falling outside. So we have 5 different statements here. I kind of like to go through each one and check which one of these do satisfy the necessary properties to negate, to be the negation of P, and which ones do not. How about this one? It is not snowing outside. If we know that statement P is true, if statement P is true, meaning it is snowing, do we know that this one has to be false? If this one is false, do we know that this one has to be true? Yeah, I would say so. If either one of these is true, the other one is false. And either one is false, the other one is true. Let me give this one a check mark. So that works as logically as the negation of P. How about this one? It is hot outside. If we know that it is snowing outside, does that mean that this one has to be false?
I feel like hot is not specific at all, and it could be 42 and something that's hot outside.
True. Hot, I would actually say this is not a statement because hot is sort of an ambiguous term. Like we don't have, it's not. To some people, 80 degrees might be hot, and to some it might not be. Say. So let's say I'm going to change this so it's an actual statement. Let's say 90 degrees Fahrenheit outside. So this is now a statement. It's something that can be, that's unambiguous as to what it means. It's either is 90 degrees or it isn't. Does this work as a negation of statement P?
I would think no, because even though logically 90 degrees means it's probably not going to snow, it's not structurally set up negating the snowing. Like it's not directly answering it.
Yeah, hot and 90 degrees and snowing are sort of opposites, but not exact opposites.
Right.
So let's ask this question. If statement P is true, if it is snowing, do we know that this is false? I'm not a meteorologist, so it's an exact answer. We could say, what if it's fake? What if we're filming a movie and it's fake snow and we're trying to film a Christmas scene in the middle of July or something? Typically, when this one is true, I would say this one is false if you're thinking snowing in the usual sense, unless we're some really crazy apocalyptic weather is happening.
However, being from North Dakota, I would know that if it is snowing outside is false, then it is 90 degrees outside definitely could be not true also. So wouldn't that violate the negation definition?
Yeah, I would say so. If this one is true, then this one's pretty much always going to be false. But if this one is false, if it's not snowing outside, doesn't necessarily mean it's 90 degrees. For instance, right now, I would say, I don't know, what is it right now, like 80 maybe? Let's say it's 80 degrees and not snowing outside. That would be a scenario where this one is false, but this one is also false. January, we'll probably have some days where it's like negative 20 degrees out, but not snowing here. That would be certainly a scenario where it is bitterly cold outside. It's not 90 degrees, but it also doesn't necessarily have to be snowing. So I would say this does not actually work as the negation. Even though they somewhat feel like, intuitively they sort of feel like opposites from each other, it is possible for one of these to not be true and the other one to also not be true. So I'm just going to write in here, could be false along with statement P.
So is the point of that example that it has to be able to go both ways?
It has to be able to go both ways. If you know either one is true, the other one has to be false. So in this case, they could both be false at the same time. They don't have the exact opposite truth values. There's lots of scenarios where one is true and the other one is false, but that's not all scenarios. How about this one? It is snowing inside. Could this work as the negation?
It was kind of previously said, but no, I don't think it would because that doesn't automatically mean it's not snowing outside.
Yeah. Like right now, for instance, I would say it is not snowing outside. I do not feel, can't lick my palm to make sure without taking my mask off, but does not feel like it is snowing inside either. So I would say this also doesn't work because both could be, this and the original statement could also be false. And in order to be the negation, if one is false, the other has to be true.
This brings up the question for me, like in seeing a statement like that, how do we know what part we're trying to negate? Because, are we negating the part that it's snowing, or are we negating where it's snowing?
Good question.
Because if you're trying to negate the outside part, then it seems like, inside would be the opposite. But if we're negating the action of it snowing, so it's kind of ambiguous in which part we're negating.
Good question. So, like another way you could say, it is snowing but not outside, or it is not snowing in the outside world. So you sort of have to think about the statement as a whole and say, it is snowing outside. Like outside, it is snowing. I guess this is a little bit of, we're saying two things. Like in the outside realm, there is snow right now. What would be sort of how could we sort of think of the opposite of that entire scenario? Meaning, what would be, how could we encompass all scenarios that are not the ones where outside right now, there is snow coming down? And really, I would say the opposite of that would just be Okay, I sort of see what you're getting at. Let me think about this for a second. It is not snowing outside. Throwing a not in there for something like this sort of encompasses all possible cases. Like, it is not the case that outside it is snowing. It would be maybe a way to kind of write this out a little bit longer, but make it a bit more clear. Like, if our original statement is, right now we are in a weather state where outside there is snow, way to negate that would be, right now we are in a weather state where it is not the case that outside there is snow. So writing something like, it is not snowing outside would negate the original in the sense that it encompasses all possible scenarios where there's not snow coming down outside. Whereas if we were to write something like, it is snowing, comma, but not outside, would encompass some scenarios other than the original, but would also not account for everything, in the sense that one way to negate it is snowing outside is there's no snow at all. Another way to negate outside there's snowing is there is snow, but only on the inside. And this encompasses both those scenarios, whereas that only encompasses the one. Does that sort of answer your question? It's sort of you have to sort of do it on a case-by-case basis. So maybe when we do a few more examples, it'll make a bit more sense.
Yeah, okay.
And I would say this last one kind of falls into the same scenario. It could be false at the same time that it is snowing outside is also false, if there's no snow on the inside or on the outside. How about this? This one, on the other hand, I think does work, because if this is true, if it is snowing outside, then this is certainly false, that there is no snow falling outside. Whereas if this is false, if it is snowing outside is false, then that means this is true. There is no snow falling outside. So I would say both of these would be statements that could work as the negation of P. Whereas these do not, because they sort of feel like the opposite, but not really. There are scenarios under which both could be false. And you can never have a scenario where both the statement and its negation are false at the same time. So this is sort of interesting. If you were to ask your English professor, do these say the same thing? What do you think your English professor would say? I haven't had an English class at Hillsdale. Some of you who are not freshmen, I assume, have. What do you think your English professor would say if they were asked the question, are these the same?
For the most part, they pretty much are the same.
They pretty much are, but they're written slightly differently. Slightly different sentence structure to them, kind of getting across the same idea, the same thought, but in slightly different ways. To a mathematician, however, I would say these are essentially the same statement. And the way we have to describe that is we can say that these two statements are logically equivalent. And what it means for two statements to be logically equivalent is they're true. If either one is true or false, the other one has to also be true or false. So if the statement, it is not snowing outside, is true, then the statement, there is no snow falling outside, must also be true, and vice versa. Whereas on the flip side, if either one of these is false, the other one is also going to be false. And so two statements like that have the exact same set of sort of truth values, one's true, the other's true, if one's false, the other is false, we call logically equivalent, and to a mathematician, they're considered to be the same statement. So that's why we can sort of say, you notice when we talk about the negation of a statement P, there's really only one statement that works as the negation of P. But what that means really is there can be multiple ways to write it, but they're all mathematically the same. Meaning they're all logically equivalent. So even though one of you might say, oh, here's the negation, someone else might say, no, this is the negation. You're both right. They're both the same thing to a mathematician, even if they aren't necessarily to, say, an English professor. Any questions about that? Let's look at a couple more. How about, let's look at this third one here. Dr. Arn eats misbehaving students. What would be a way in which we could negate that statement?
Dr. Arndt does not eat misbehaving students.
Dr. Arn does not eat misbehaving students.
Dr. Arn never eats misbehaving students.
Dr. Arn never eats misbehaving students. Regretting using the word misbehave, it takes a long time to write. Should just sit down.
Dr. Arn does not eat.
Dr. Arn just does not eat. He is an immortal being that does not require sustenance.
Dr.
It
Arndt,
wouldn't surprise me, by the way.
Dr. Arndt eats behaving students.
Dr. Arn eats behaving students. Look out. Okay, let's try going through each one of these. So our original statement is Dr. Arn eats misbehaving students. And what we'd like to do is to find a statement that's true if the original one is false, and is false if the original one is true. What about this one? Dr. Arn does not eat misbehaving students. If this is true, if the original statement is true, do we know this one has to be false?
Yes.
If the original statement's false, do we know this one has to be true?
Mm-hmm.
Yeah, I would say so. I think this works as the negation of R. Eats and never eats. How about this one? If we know that the original statement is true, do we know that Dr. Arn never eats misbehaving students is false? I'd say so. If he does eat misbehaving students, then we can't say, then we know, or if this is true, then we know we're not in a scenario where he never eats from. If this one is false, Dr. Arn eats misbehaving students, do we know this one is true?
Well, the never is just introduces a stronger sense than the original.
It does.
So I don't know if it could be opposite.
Let's here. It's a little bit unclear maybe what the original statement is saying. So let's throw this word in here. Sometimes. Well, no, because that changes the first one. It depends on what you mean, I guess, by Dr. Arndt eats misbehaving students. If you mean he eats all misbehaving students, then I would say this does not work as the negation, because maybe he eats some misbehaving students but not others. If by Dr. Arndt eats misbehaving students, we mean sometimes he eats misbehaving students, then the negation of that would be he never eats misbehaving students. And these are sort of the more complicated statement types we're going to be looking at in Standard 2. Ones with sometimes and always and such. So for now, there's a little bit of ambiguity, and we'll come back to that one. Dr. Arndt does not eat. You ever seen him? You ever seen him with food in his mouth? I haven't. What are your thoughts on this one?
I think that if it's true that Dr. Arndt does not eat, then it is false that Dr. Arndt eats misbehaving students.
I would agree.
But if it's false that Dr. Arndt eats misbehaving students, he could still eat other things.
So if this one is false, there is a scenario under which both of these are false in other
Right.
ways. Yeah, maybe Dr. Arndt doesn't eat students, but he eats broccoli or steak. The Hillsdale professor, you get invited to lots of fancy events where you have dinner with all the faculty, including Dr. Arndt. I can assure you he does actually eat on occasion, in case you were worried. But this one does not work because R and this statement could both be false at the same time. If this one is true, then we know this one has to be false. But if this one is false, we don't know that this one has to be true. And finally, Dr. Arndt eats behaving students.
That one could be true along with the misbehaving true, and it could also be false along with that one is false.
Yeah, I agree. Maybe Dr. Arndt doesn't eat any students at all. I suspect that might be the case, but you never know. In which case, if Dr. Arndt never eats any sorts of students, then both of these are false. But maybe Dr. Arndt isn't a picky eater. Maybe he eats all students, and you should transfer now before you get to your senior year, and you're his main course one night. So this one I would say is also false in the sense that, is not the negation in the sense that both could be true and both could be false. So the moral here with these sort of relatively simple types of statements, if you're trying to negate and you're trying to account for all possible cases, throw the word not in there and try to change nothing else. It's the simplest way to do it. It will get more complicated next standard when we're talking about how you would negate something like Dr. Arndt eats some students or Dr. Arndt eats every student. Getting those can be a little bit trickier. But for now, oftentimes it'll be easiest just to kind of throw in the word not and try and leave the rest of the sentence structure the same in order to avoid as much ambiguity as possible. Any questions about either of these?
This is a totally off-the-wall question. Hopefully it doesn't derail anything. But
I'll be the judge.
Okay, yes, you can be the judge of that. In the inquiry concerning human understanding with Hume, if I recall correctly, one of his ideas was the idea of we only judge the future probabilistically. So I was kind of thinking about that with this question, I guess, in some ways. Because it seems, or the Dr. Arndt eats misbehaving students, it seems kind of confusing in the sense of when exactly is he doing it, or when might he do it.
Yeah, which is why in retrospect I wish I'd written this a bit more clearly. We could say he sometimes eats misbehaving students. Does he eat all misbehaving students? It's a little bit unclear from the way the question is stated. We can give it we can sort of give an answer like this that sort of also is a little bit ambiguous, and that captures the essence of it's the opposite of the original.
Mm-hmm.
But you're right, there is a little bit of ambiguity sometimes, which is why it's helpful to write statements as clearly as you can, I think. All right, a couple more on this page I encourage you to try for fun. We'll move on to the next one. Statement S. Aristotle owned a Nintendo Switch. Those ancient Greeks really loved those 3-year-old video game consoles, I tell you. 3 years old now. How can we negate that statement?
The Nintendo Switch was not invented when Aristotle was alive.
Ooh, that's it. Is that your negation?
Yeah, that's my negation.
Okay. What do y'all think? If Aristotle owned a Nintendo Switch is true, do we know this one has to be false? It was false that the Nintendo Switch was not invented when Aristotle was I would say so. If this is true, if he owned one, then they certainly had to be around when he was alive. So if this is true, I would say this one has to be false. Let's say Aristotle did not own a Nintendo Switch. Does this have to be true?
No.
I don't think so. Maybe they were around at the time, but Aristotle didn't like playing video games, and he just didn't happen to own one. Also keep in mind, we might not be talking about the Greek Aristotle. Maybe we're talking about someone else named Aristotle who's alive today. I never specified. So I don't think this quite works as the negation. I would say this is certainly a true statement in the context of the actual world, whereas this is certainly false. But it doesn't quite work as a logical negation of that. So how else could we try to negate Aristotle owned a Nintendo Switch?
Aristotle did not own a Nintendo Switch.
Aristotle did not own a Nintendo Switch. I like it. No matter what person Aristotle we're talking about, if he owned a Switch, if it's true that he owned a Switch, it's false that he didn't own one. And if it's false that he owned one, then it must be true that he didn't own one. Let's do something a little bit unorthodox. How can we negate the negation? In other words, if now the statement that we want to negate is Aristotle did not own or didn't own a Nintendo Switch, how could we negate this sentence? Aristotle did own a Nintendo Switch.
Is that logically equivalent to the first sentence, Aristotle owned a Nintendo Switch?
What do you all think? Is S and negation of S logically equivalent here? Aristotle owned a Nintendo Switch. Aristotle did own a Nintendo Switch.
Yes.
I would say so. To an English professor, they might say, no, this one tries to emphasize the fact that he did more and is made more refutation of the fact that he didn't in the original statement. But to a mathematician, these are logically equivalent. How about this one? Aristotle did not own Nintendo Switch. Would that also work? See a lot of nodding. Yeah, I would say that's another way that you could phrase the negation of S. Dr. Gerstle, double negatives are bad. Not to a mathematician, although they are a bit weird. And you could just cancel them out. Technically, if I wanted to, I could say Aristotle did not own a Nintendo Switch, and that would also be logically equivalent. an even number is not said so that they cancel each other out. Or, I could just do statement S again. Aristotle owned a Nintendo Switch. Would be a way you could negate Aristotle didn't own a Nintendo Switch. So all of these are going to be logically equivalent. Meaning, if any one of these is true, the others must also be true. And if any one of these is false, the others must also be false. And it turns out that we can make the claim that in general, it doesn't matter what your original statement is. Your original statement, for any statement P, P is logically going to be equivalent to the negation of the negation of P. Doesn't matter what your original statement was. If you negate P and then you negate that negation, you're going to end up with something that's logically equivalent to your original statement. The reason is if P is true, then what do we know about the negation of P? False. P is true, the negation of P is false, which in turn tells us what has to be true about the negation of the negation of P.
It has to be true.
Yeah, if the negation of P is false, then the negation of that has to be true. And we can say vice versa. If P is false, then the negation of P is true, which means the negation of P has to be false. So in other words, whenever P is true, negation of P has to also be true, and if P is false, the negation of P is also going to be false. So it doesn't matter what your statement P says. Whether it's something silly like Aristotle owned a Nintendo Switch, came out in 2017, or it's something as simple as it is snowing outside, P and negation of P are always logically equivalent. Any questions about negations or logical equivalence? Okay, let's go into our last topic for today. The idea of sets of statements being contradictory. So in general, we're going to say that a collection of, good, it's still recording, statements is contradictory if it is impossible for all statements to simultaneously be true. So we're on the second to last page of the handout now. So if there is a scenario, at least one scenario, where all of them could be true, we say it's not contradictory. But if no possible scenario would allow all of your statements to simultaneously be true, then we say it's a contradictory set of statements. So let's look at this one. This shape has exactly 4 sides. And let's say we are also saying this shape has exactly 6 sides. Is it possible for both of these to simultaneously be true when looking at a shape? Assuming that we know these refer to the same shape.
Refer to the same shape. that can't be true, because it can't at the same time have exactly 4 sides and exactly 6 sides.
Yeah, it can't have 4 sides and 6 sides both.
I mean, if it didn't have exactly, then you could get a little more like, well, it could have 4 sides and have 6 sides at the same time, because you didn't just count all 6 sides.
True. Technically, a hexagon does have 4 sides, and just happens to have 2 more as well.
Yeah, but exactly really specifies it.
Yeah, I would say so. If this first one is true, the second one cannot possibly be true, and vice versa. Is it possible for both of these statements to be false at the same time?
Yes.
I would say so, like a pentagon, something with 5 sides. That would make both these statements false. But there is no circumstances under which both can be true, so this set of statements would be contradictory. Both can't simultaneously be true. Let's look at a couple more. So I want you to think, there's several more examples on this page and the next page, and most of these examples I want you to look at on your own. So I'm going to put up on the board 2 examples that I'd like to talk about as a class. So first one is Donald Trump will be president next year. Joe Biden will be vice president next year. And finally, Kanye West will be Secretary of State next year. So that's one I want you to look at. So the third one on this page. And there's also one on the back page I'd like for you all to look at, which is the statement below is true, the statement above is false. Did I put those in the right order? Yes. So I want you to take just a couple minutes, talk to the people sitting around you if you feel comfortable. If not, you don't have to, certainly. And see if you can decide whether these 2 sets of statements are contradictory or not contradictory.
Well, sure.
Is it like
Keep in mind that contradictory does not mean the same thing as impossible. Or no, it does mean impossible for both to be true. It doesn't mean the same thing as being unlikely or likely. Possible doesn't mean
I think it's like that line the other day.
Yeah.
What?
Right, so yeah, like as of right now, it's that means the bar the first one, are we talking about like the way that it is right now, or like there's like a possibility for change?
You have to account for all possible scenarios that are logically possible.
Okay.
Logically, and it could be you could consider scenarios as absurd as it is logically possible that we change the rules for who can be elected president, and a year from now, an orangutan is president of the United States. Likely? No. Possible? Yes.
Okay, it's true that this is false.
So that probably says bad things about the state of work.
Yeah.
Yes.
So if we start with this one and say, statement above is definitely
Yeah,
true.
the logic of the statement
Sorry,
still
Bob. Statement
I mean, this
below.
one's hard.
true, yeah, it will happen.
But this one
Would
is
make
false.
this false. So they
I was
want,
just looking at that one's actually.
If you finish thinking about these, go ahead and start taking a look at some of the other sets of statements here, and we'll come back in about a minute from now and talk about these two sets in the class.
Yeah, what about this yeah, English
Statement below is true, the statement above is false. They can't both be true, right? Yeah. So if the one below is true, then the one above is
Because
false.
this is where the math is like, right, there's some kind of.
Yeah.
okay, so this
Yeah,
here
it doesn't
would
work.
work Friday, 2 days before Friday. So 1 week after Saturday, yeah. Wait, no, the day after tomorrow, which is Sunday.
I think, yeah.
And that's a week after Sunday.
Yeah, so every English paper.
Best way to look at the days of the week one might be to try and figure out what today is.
Yeah. So 2 days before Friday is Wednesday. 1 week after, the day after tomorrow. Day after tomorrow.
Okay, let's come back and look at this political one here. What do you all think? Donald Trump will be president. Joe Biden will be vice president. Kanye West will be Secretary of State. Is that a contradictory set of statements?
It's not contradictory. It'd be very frightening that Joe Biden could decide to run for VP and have Kamala run for president, so.
But can these both be true simultaneously where Donald Trump is president and Joe
Oh,
Biden
yeah,
is vice
that's true.
president?
I did not think about that.
Yes.
All these have to be simultaneously.
Yeah, they're not contradictory, I think, because some crazy thing could happen and it could happen. And it would not these statements would not logically contradict each other. So in reality, it could happen, although the probability of it happening is vanishingly small.
I agree. Logically speaking, there is no reason why these three events can't all happen or can't be true. However, it is, I agree, extremely unlikely and requires probably things we don't want. I don't want to have happen in the elections coming this year. So, non-contradictory. But very unlikely. Unlikely, but possible that all of these come true. So the moral is, just because you don't think something is likely to happen at all does not mean you have a contradictory set of statements. Contradictory here would be Donald Trump will be president, Joe Biden will be vice president, Joe Biden will not be vice president. That would be a contradictory set of statements because Joe Biden can both be and not be vice president next year. How about this one? Statement below is true, statement above is false. Is that a contradictory set of statements?
I would say yes. You could say that if the first statement is false, they could both be false, but they can't both be true.
So
Because it's they're self-reflexive like that other one that one we were doing the other day. About where they was just talking about the
this
statement
statement, this statement is false.
Yeah, so I think they're contradictory.
And that one we said is not even a statement. These were referring to other statements, but I do agree that they can't both be true because if the top one's true, the bottom one can't be true. Is it possible for both these statements to be false?
Yes.
Well, the bottom one's false, then if this is false, then shouldn't the bottom statement have to be true?
They can't even both be false.
They can't both be false. We also can't have a scenario where one is false and the other is true. This is another paradox. Something where there is no way to assign truth or false values to both statements simultaneously. Also, both, well, we can't have both false or one false. Have both false or one false, one true. There is no way to fill these in, so we have a paradox. But the fact that both can't simultaneously be true is enough to tell us that this is a contradictory set of statements. There's no way for both top and bottom to be true at the same time. Great. Just so you know, I encourage you to try the rest of these on your own. Later today, I will be posting solutions to this whole packet on Blackboard, so you can check your work on the other ones based off what I did. And that's going to do it for Standard 1. When we come back on Wednesday, we're going to start Standard 2. Talk about slightly more complicated statements with words like all and some mixed in, and how that makes your statements treated differently. Hope you all have a good rest of your day. I'll see you all on Wednesday.